So now that we've found our shape, center, and spread, we can answer some important questions like probability, which is where they're having us head for the next question. It says, what is the probability that a random sample of 20 pregnancies has a mean gestation period of 260 days or less? See that? Now I know what you're thinking. You're thinking, wait, didn't we do less than 260 up here? In part A, yes, we did, but that was for a single woman, a single pregnancy. Now I'm talking about taking an average of 20 random pregnancies. What's the probability that their mean, their average, is less than 260? All right, so I'm talking about the probability that X bar is less than 260, not X anymore. I'm talking about an average now. All right, it's going to be the same formula. It's still norm dist. It's still 260. It's still 266, but the standard deviation is now this number, 3.5777. True. There we go. And I used the cell reference. That way it keeps it nice, keeps all the decimal places. There we go. So the other numbers, it doesn't matter, but for the standard error, you can see I used that. Of course, if you want to use the cell reference for 266, that's fine too. All right, there we go. That's that. Now notice, by the way, how much smaller this is than the answer we got for A. The chance of a single woman having a pregnancy less than 260 is almost 35%. I mean, 1 out of 3. But having a group of 20 women, random women I might add, having their average be less than 260, that only happens 5% of the time. Much rarer, much harder to come by. All right, now for part D, it's still less than 260 days, but it's talking about 50 pregnancies now instead of 20. So the first thing we're going to have to do is find our new standard error. That's going to be the sigma, which is 16, divided by the square root of n, but n in this time is 50, not 20. That lowers the spread even more, right? I mean, if you think it's hard for a random group of size 20 to be far apart, it's even harder for a random group of size 50 to be far apart. All right, now we want the probability that X bar is less than 260 again, but now we're talking for this group. So it's norm dist. X would be 260. The mean is 266. Standard deviation is now this cell right here. True. Just on a side note before I go anywhere, I want you to notice we were kind of lucky that all these problems were actually asking for less than probabilities. Remember, that's what the one that norm dist comes with. Norm dist gives you left tail probabilities, less than probabilities. If any of these problems had been greater than, I would have been stuck doing 1 minus these answers for every single one of them because I would have needed the complement rule to do that. Just keep that in mind. All right, so there we go. I've got X bar right here. Now notice, look, this is even smaller. I mean, if you think it's hard for a group of size 20 women to have their average be less than 260, think about what it would mean for a group of size 50 random pregnant women to have their average be less than 260. It's very hard to do. This leads us to question E, which is a thinking question. It says, what might you conclude if a random sample of 50 pregnancies resulted in a mean gestation period of 260 days or less? For example, let's suppose, I don't know, you get 50 random pregnancies in Haiti right now. What could be going on? What could be some things that could be happening? It could be that it was an unbiased sample, right? Excuse me, not an unbiased, I'm lying. A biased sample. Right? Maybe they were only able to look at, X, Y, and Z. It could be that there are external factors. I mean, I picked Haiti because of the earthquake and the poverty and such. It could be that maybe the data was taken wrong, right? Maybe it wasn't less than 260. Maybe there's some typos in the data collection. Or it could be that 266 is not the mean for pregnancies, for pregnancy length. Right? I mean, if all else fails and it's not a biased sample and it's not external factors, then maybe it's just that your data was wrong to begin with. Maybe women aren't carrying babies as long as they used to anymore. Who knows? Right? So those are just some ideas, but you can write up, of course, whatever you think might be happening for your example. I think we're all done with that number 21. So next time we're going to move on to number 33.